don't mess with fakes, only real. Yeah, let me tell you about these real numbers.
What's going on, class? It's your favorite math teacher here, bringing you a lesson on real numbers. Think of real numbers as every single number imaginable, and each set of numbers has a specified name for it. You have natural numbers, whole numbers, integers, rationals, irrational numbers, and then you have lastly real numbers, which embodies every single set of numbers that I just named. These are all called number sets. Sounds confusing at first, but I'll explain more in detail. Natural numbers are going to be the beginning of all the sets. It's going to be where we first start to count our numbers, starting at 1 and then all the way up to infinity. Natural numbers are also what we call our counting numbers, because it's the numbers that we can count with our fingers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then all the way up
to infinity and beyond.
Natural numbers can be thought of as the beginning because it's going to include every set that you're going to see that I'm going to name as we go along further. Next, we have whole numbers, which is the same as natural numbers. Only difference is whole numbers include the number 0, which is very easy to remember. Because if you think about it, a whole is empty. And we can think of whole numbers as having an empty number, which that empty number would be 0. Therefore, giving its name, whole number. So a whole number set includes 0 and natural numbers, which is what we counted previously. So it would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
To infinity.
Then we have the integers, which tends to confuse a lot of students. If natural numbers is the beginning, or what we used to count with, and then whole numbers is going to be next in line, then integers is going to include both sets of numbers, both natural numbers and whole numbers. But what makes integers different from the other two sets is that it also includes negative whole numbers. So not only does it have positive, but it also has negative whole numbers as well. And that's what makes integers different. So integers count from positive infinity all the way down to positive 3 to 2, 1, 0, and then -1, -2, -3, and all the way down to negative infinity, which will be on the lower end of our numbers. And another thing that's really important, because a lot of students make this mistake. Although integers include negative numbers, they cannot have negative fractions or negative decimals in them. They can only be negative or positive whole numbers. I'm going to say that one more time. Integers can only be negative whole numbers or positive whole numbers. They cannot be fractions, nor can they be decimals. Moving on to rational numbers or ratio numbers, which include all the three sets that we previously mentioned. The difference with rational numbers is it includes both fractions and decimals, both positive and negative. So this set counts negative infinity, negative fractions, negative decimals, negative whole numbers. Then they count positive whole numbers, positive decimals, positive fractions, and all the way up to positive infinity. Oh yeah, and I have something very important about rational numbers that I must mention to you that can be really tricky. Rational numbers can have decimals that repeat, or what we call repeated decimals. For example, 1.222222, and the 2 repeats forever. You may have seen repeated decimals written in this form, 1.2 with a line over the top of the 2, which just means the 2 repeats forever. In a bit, you will see that this is what separates a rational number from an irrational number. So now you have irrational numbers, which is kind of like the oddball of the other sets. It kind of stands alone by itself, but it's still a real number. What separates irrational numbers from all the other sets of numbers is that it can never be a rational number. It cannot be a rational number. In fact, that's how it gets its name, irrational, because it can never be a fraction or a rational number. It cannot be a rational number. Also, irrational numbers has another unique quality to it. Decimals can go on forever and never repeat the same number twice in a row. A great example of this is the symbol pi, which if you're not familiar with pi, it looks like this. And when you type pi into your calculator, you get this long decimal that goes on forever, and decimal numbers never repeat. So pi will be a part of the irrational number set because decimal numbers never repeat. And before I move on, another really important thing about irrational and rational numbers is that they can also be under what we call a square root, which looks like this. If you have never seen square roots or you don't know how they work, don't get too wrapped up in that for right now. What you must know is that if the number underneath the square root can be found by multiplying the same number twice, then that is a rational number. Like the square root of 16. We can find that 16 that's underneath that root by multiplying the same number twice, which would be 4, because 4 times 4 is 16. So this is a rational number. But if we look at the square root of 14, you will see that there isn't 2 numbers that we can multiply twice to get that number. Therefore, it's an irrational number. To further understand, let's look at another example. The square root of 36. Is there a number that we can multiply twice to get the number under the root? Absolutely. We can multiply 6 2 times and we'd get 36, which is a rational number. Let's try one more example. What about the square root of 40? Is there a number we can multiply twice and get 40? No, there isn't. In this case, the square root of 40 would be irrational. Simple, right? So every single set of numbers that I just mentioned to you are called real numbers. Real numbers are basically any number that you can imagine. They can be whole numbers, they can be decimals, they can be fractions, they can be negative numbers, they can be irrational numbers. It doesn't matter. Any type of number you can think of can be a real number. Now that you know what real numbers are, let's do a few examples. Let's look at the number 27. This number will fall under what set or sets of numbers? Absolutely. 27 falls into numerous sets. It falls into natural numbers, whole numbers, integers, rational numbers, and real numbers. So 27 is a part of a lot of sets. Let's do another one. -4. Do you know this one? All right. It's an integer, a rational number, and a real number. All right, let's try something that's a bit more difficult. -1.2 repeated. What kind of number is this? It's a rational number and a real number. You may be wondering, I thought it was irrational. But remember that irrational numbers do not repeat the same number or decimal twice in a row. Let's try another one. 12.347896 and so on. What set is this number a part of? Yes, indeed. It is an irrational number and real number. It is an irrational number because the decimals, they do not repeat. And that just about does it for this episode on real numbers. Now that we know what real numbers are, let's move on to practicing them. And I don't have to tell you, because you already know, that this is why I like math. See you next time. Holla!
Only measure real. Yeah, 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 yeah. Yeah. Hope y'all got that. You wanna hear it again? Just play it back. Yeah. Let me tell you about the real numbers. Yeah. Let me tell you about the real numbers. Yeah. Let me tell you about the real numbers. Yeah. I'ma tell you about the real numbers. Yeah. Let me tell you about the real numbers. Yeah. Let me tell you about the real numbers. Yeah. Let me tell you about the real numbers. About the real numbers. I'm about the real numbers.